Well, hello and welcome to our webinar. I'm Tom Sandry, the Director of Workforce Development at Vector Power, and today we're going to explore trigonometry. So, without further ado, let's get started. Trigonometry is a branch of mathematics that studies relationships involving lengths and angles of triangles. The name trigonometry is taken from Greek trigonon, or triangle, plus metron, or measure. So we can see trigonometry literally means the measure of triangles. So why is this important to anyone involved in electricity? In a right triangle, there are several relationships which always hold true. These relationships pertain to the length of the sides of a right triangle and the way the lengths are affected by the angles between them. An understanding of these relationships, called trigonometric functions, is essential for solving problems in alternating current or AC circuits, such as power factor, impedance, voltage drops, and so forth. A triangle has three sides and three angles. The three angles always add to 108 degrees. There are three special names given to triangles that tell us how many sides or angles are equal. So we have the equilateral triangle, where three equal sides and three equal angles, always 60 degrees. The isosceles triangle, with two equal sides and two equal angles. And the scalene triangle, with no equal sides and no equal angles. Triangles can also have names that tell us what type of angle is inside. So we have the acute triangle. All angles are less than 90 degrees. The right triangle, it has a right angle of 90 degrees. And the obtuse triangle, which has an angle more than 90 degrees. The triangle of most interest is the right angle triangle. The right angle is shown by the little box in the corner. Another angle is often labeled theta, and the three sides are then called the adjacent or next to the angle of theta, the opposite the angle of theta, and the longest side is called the hypotenuse. Trigonometry is about right-angled triangles, where one of the internal angles is 90 degrees. Trigonometry is a system that helps us to work out missing sides or angles in a triangle. The main functions in a triangle are sine, cosine, and tangent. They are simply one side of a right-angled triangle divided by another for any angle of theta. So sine of theta would equal the opposite divided by the hypotenuse. Cosine of theta would equal the adjacent divided by the hypotenuse. And tangent of theta would be the opposite divided by the adjacent. To help you to remember these functions, think of SOHCAHTOA. Write these functions down or simply remember SOHCAHTOA. You're going to need reference to this as we progress in this webinar. So let's start with our first example. What is the sine of 35 degrees? Well, let's work through our SOHCAHTOA model. Sine of 35 would equal the opposite divided by the hypotenuse, which would be 2.8 divided by 4.9, or the sine of 35 degrees equals 0.57. All right, let's look at a little bit more of a practical application. What is the height of this tree? Well, let's start with sine of 45 degrees would equal the opposite divided by the hypotenuse. On the calculator, press the sine key, then type in 45. We see that the sine of 45 degrees equals 0.7071. So now we can put what we know into the equation. 0.7071 equals the opposite divided by 20. Now let's go ahead and just simply swap sides. Say the opposite divided by 20 equals 0.7071. Now what we want to do is we want to get opposites standing alone. So we can multiply both sides by 20. 20 divided by 1 times opposite divided by 20 would equal 0.7071 times 20, or that simplifies down to the opposite equals 0.7071 times 20. And now we're ready to solve. The opposite, or the height of the tree, equals 14.14 feet. All right, how far from the tree is the man? All right, why don't you guys try to work this one on your own? Take a few moments, come up with your calculation, and then we'll review. All right, let's go ahead and work through together and see if you got the right answer. Let's start with tangent of theta would be equal to the opposite divided by the adjacent. On the calculator, press the tan key, then type in 30, and we see that the tangent of 30 degrees equals 0.5774. All right, so we can now put in what we know. 0.5774 would equal 15 divided by the adjacent. Now again, we can go ahead and multiply both sides by the adjacent, and that would allow us to simplify down to the adjacent times 0.5774 would equal 15. We can now divide both sides by 0.5774, and that would simplify down to the adjacent equals 15 divided by 0.5774, and we can solve, and the man is 26 feet from the tree. Is that what you calculated? If so, congratulations. All right, let's do another one. Using the distance from the tree, what is the hypotenuse? All right, why don't you try this one on your own again, and then we'll review. All right, to solve this, let's start with cosine of theta, and we know that that is the adjacent divided by the hypotenuse. So on the calculator, we press the cosine key, then type in 30. We see that the cosine of 30 degrees equals 0.866. Now again, we can use substitution and put in what we know. 0.866 equals 26 divided by the hypotenuse. We multiply both sides of the equation by the hypotenuse, and that allows us to simplify to hypotenuse times 0.866 equals 26. We now divide both sides of the equation by 0.866. That will simplify to the hypotenuse equals 26 divided by 0.866, and now we can solve. The hypotenuse is 30 feet. Is that what you got as your answer? If so, congratulations. In fact, congratulations. You just successfully used the sine, the cosine, and tangent function in practical applications. All right, next let's look at inverse sine, cosine, and tangent. As we've just learned, trigonometry functions such as sine, cosine, and tangent take the angle theta and give us the ratio of the sides of a right triangle. For example, the sine function takes angle theta and gives the ratio opposite divided by hypotenuse. The inverse sine function, or arc sine to the -1, takes the ratio opposite divided by hypotenuse and gives the angle of theta. Cosine and tangent follow a similar idea. So, as we see, the functions are like forward and reverse. Sine, cosine, and tangent gives us the ratio of various sides, and inverse, also referred to as arc, or arc sine, arc cosine, and arc tangent, gives us the angle. Now let's talk a little bit about the unit circle. In mathematics, a unit circle is a circle with a radius of 1. Frequently, especially in trigonometry, the unit circle is the circle of radius 1 centered at the origin coordinates 0, 0 in the Cartesian coordinate system in the two-dimensional plane. As we move counterclockwise around the unit circle, other key coordinates for x and y become 1, 0, 0, 1, -1, 0, and 0, -1. If x and y is a point on the unit circle circumference, then x and y are the lengths of the legs of a right triangle whose hypotenuse has length 1. To show this, let's say that the point on the circumference has coordinates a, b. To make this part of a right triangle, we drop an altitude from that point to create a right triangle. As we see, the amplitude line that was dropped in the opposite side of the angle theta its value is equal to the y-coordinate, or intersection. So this line will be equal to b, or the y-coordinate. The length of the adjacent side of the angle theta will be equal to a, or the x-coordinate. Now, let's think about sine and cosine functions. Remember the SOH-CAHTOA definition. So, what is the cosine theta equal to? Well, as we see, cosine theta is equal to the adjacent side divided by hypotenuse. Therefore, cosine theta equals A divided by 1, or simply is equal to A. What about sine theta? Well, sine theta equals the opposite side divided by the hypotenuse, or B divided by 1, or simply B. So we can also view our AB as A is the same thing as cosine theta, and B is the same thing as sine of theta. This SOHCAHTOA model works well as long as we're working with a right triangle and a defined right triangle, but begins to break down when our angles become 0 or become negative, as our angles become greater than 90 degrees. So, let's set up a new definition of our trig functions, which will really be an extension of SOHCAHTOA. Instead of saying that sine equals opposite over hypotenuse, or cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent, why don't we say for any angle we can draw in the unit circle using a counterclockwise rotation, and that the cosine of the angle is equal to the x-coordinate where the terminal sides of the angle intersect the unit circle. And we can define sine and theta as equal to the y-coordinate where the terminal side of the angle intersects the unit circle. So essentially, for any angle, the AB point is going to define cosine of theta and sine of theta. What about a reasonable definition of tangent of theta? Well, tangent of theta, even with SOHCAHTOA, could be defined as sine of theta divided by cosine of theta, which in this case will be the y-coordinate over the x-coordinate. And now we know that trigonometry is also about circles. Here we can see the sine function being made by the unit circle. As we can see, the unit circle and trigonometry functions will be very useful in our studies of alternating or AC current in electricity. All right, let's talk about this thing called Pythagorean theorem. Over 2,000 years ago, there was an amazing discovery about triangles. When a triangle has a right angle, 90 degrees, and squares are made on each of the three sides, the biggest square has the exact same area as the other two squares put together. It's called the Pythagorean theorem and can be written in one short equation. A squared plus b squared equals c squared. Now note, c is the longest side of the triangle. A and b are the other two sides. We know that the longest side of the triangle is the hypotenuse. So the formal definition of Pythagorean theorem is, in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So, let's check if the areas are the same. 3 squared plus 4 squared equals 5 squared. Calculating this becomes 9 plus 16 equals 25. Hey, look at that. It works. All right, so why is this useful? Well, if we know the lengths of two sides of a right triangle, we can find the length of the third side. But remember, it only works on right-angled triangles. To use it, write it down as an equation. A squared plus b squared equals c squared. Then, we simply use algebra to find any missing values. So, why don't you go ahead and take a crack at it? Let's solve this triangle. Take a few moments and let's find the value of c, the hypotenuse. All right, let's work through this. We'll start with a squared plus b squared equals c squared. Now, we do substitution and put in the values that we know. So 5 squared plus 12 squared equals c squared. We calculate the squares. So 5 squared is 25, 12 squared is 144. 25 plus 144 equals 169. So 169 would be equal to c squared. Let's go ahead and swap sides. And we'll take the square root of both sides. And now we see that c is equal to 13. Is that the answer that you calculated? If so, congratulations. All right, let's solve this triangle. We'll work through it together. Once again, we'll start with a squared plus b squared equals c squared. And we'll substitute and put in the values that we know. Now we'll calculate the squares. So 9 squared is 81, b squared we don't know yet, and 15 squared is equal to 225. Now we take 81 from both sides, and that leaves us with b squared equals 144. Take the square root of both sides, and we see that b equals 12. All right, moving on, we'll now take a look at the difference between radians and degrees. Radians and degrees are two different units for measuring an angle. The degree is the older way of measuring angles dating back to ancient times. Radians are actually a more effective method of measuring an angle, although a bit more complicated. It is in fact the International System of Units, or SI unit, for measuring an angle, even if the degree is the more commonly used. Radians and degrees are two different units for measuring an angle. One of the first things we learn in mathematics is how to measure an angle, whether it is a 45-degree angle, a 90-degree angle, and so forth. Effectively, we're taught that angles are synonymous with degrees. However, it is in our advanced study that we learn of radians. Each degree represents 1 divided by 360 of a full rotation. This means that each circle is divided into 360 degrees, and each movement is counted as 1 degree. So if we move 5 times from the starting point 0 degrees, then it is 5 degrees, or 10 degrees, then 15 degrees, and so forth until we reach back to 0, making a full 360-degree rotation around the circle. Now, the actual reason why the ancient people divided the circle into 360 degrees is unsure. However, the most popular theory states that the ancients believed the year was made up of 360 days. Example, 12 months of 30 days each, and each day the sun moved a little on the horizon from where it was the previous day. Example, 1 degrees. Also, the 360 degrees makes it somewhat simpler to break down the circle. Hence, half a circle is 180 degrees, a quarter circle is 90 degrees, and then 45 degrees, and so forth. However, this system is somewhat limited. First, the 360-degree system does not translate well into other mathematical calculations, as they are not based on the 360-degree system. Hence, the radian came into play. The radian was in use since as long ago as the 1400s. However, it was not adopted as an accepted unit until the late 1800s. The concept of a radian is a bit more complicated than the degree. The radian is based on the radius of a circle. The radius of a circle is any line drawn in the circle that connects the center of the circle to the circumference. This line is then taken and measured around the circumference of the circle. When the beginning point of the line and the end point of the line are connected to the center, the lines form an angle. This angle is known as 1 radian. This radian can then be measured into the circle to see how many radians it takes to measure one circle. However, the answer is not straightforward. It takes 3 radians to form almost half a circle. However, even after 3 radians, there's a little bit of circumference left over. Hence, the official measurement is that a half of a circle equals 3.14 radians, or 3.14 rad. This is commonly written as pi rad, or simply pi r. Therefore, one circle equals 2 pi rad, or 2 pi r. Since one circle is equal to 2 pi r, and we know that one circle equals 360 degrees, therefore it could be written that 2 pi r equals 360 degrees. Pi r would then equal 180 degrees. 1r equals 180 degrees divided by pi, and 180 degrees divided by 3.14 gives us 1r equals approximately 57.325 degrees. This can be used to convert between radians and degrees. However, this table can help with some of the more common conversions. All right, in summary, trigonometry is the study of measuring triangles. Trigonometry focuses on right-angled triangles. Sine, cosine, and tangent are trigonometry functions that give us the ratio of various sides of a triangle. Arcsine, arccosine, and arctangent are trigonometry functions that, based on the ratio of sides, gives us the value of the angle. In mathematics, a unit circle is a circle with a radius of 1. Pythagorean theorem states, in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Radians and degrees are two different units for measuring an angle. And that concludes our webinar today on trigonometry. Hey, if you like our content, please subscribe to the channel, hit the notification bell so that you're notified of up-and-coming webinars, and please remember to hit that like button. All right. Thank you once again for your participation today, and until next time, I'm Tom Sandry.